So welcome to another lecture. In this lecture, we'll be solving a geometry problem. Usually, all these Olympiad problems, geometry is a topic I really like to solve. So we have been given that this is a square. This is a square whose area is 5 meters square. Whose area is 5 meters square. And what we have to find is we have to find the length of this chord CB. We have to find the length of chord CB. So this is the question. Now there are few things which I understand before even I start the question, because it's a square. The area is 5 meters square, so I understand that the each side would be equal to root 5. So for the square, each side would be root 5. So this would be root 5. This would be root 5, and so on. So this would be root 5. So this is the first thing I understand. Now once I have this uh, root 5 and root 5, then I understand that this diagonal OE, the diagonal OE, I can apply Pythagoras. So root 5 square plus root 5 square is 5 plus 5 is root 10. So this diagonal EO would be root 10. Now there's a beautiful thing which has happened. I hope you saw that. If this diagonal is root 10, then basically you have the radius of the circle. So there's a great thing which has happened, because you'll understand now that this root 10, now this one is also root 10. And I have completed the semicircle. This OG would also be root 10. Why do I require OG? You'll understand in few minutes. But the radius of this circle, full circle, is root 10. Now if you look closely, this is root 5. This is root 10. Again I use Pythagoras. Then 5 plus 10 is root 15. So this dB is root 10. Now I'll show you where exactly have I reached. I will delete all this, and then I'll show you where have I reached till here. See, I had to find the length of this whole chord. I have found the length of this part. This is root 10. So all I need to find now is this part y. Now let me review where I have reached till here, so that you are with me till here. It's a beautiful question. I liked it a lot. Very well constructed question. So let's look. So area is 5 meters square. So side is root 5. So each side is root 5. Okay. So diagonal is root 10. I have found the diagonal which is root 10. So using the diagonal, I know that the radius is 10. The radius of the circle is 10. And using the this root 5 and root 10, I have found dB. This is BD, or dB is one and the same thing. So this is root 15. So I found this to be root 15. So this is what we have discussed earlier. And now we need to know this intersecting chord theorem. So intersecting chord theorem is part of class 10 syllabus. It's part of ICSE syllabus. So it's not that something which is way beyond. So what does the intersecting chord theorem say? It's a very simple theorem. All it says is that if you have a circle like this, let me make some space. Maybe I'll explain it. Yeah. So if I have a circle like this and there are two intersecting chords, so let me call this A, B, C, and this as X, B, Y. So all the intersecting chord theorem says is that AB into BC would be equal to xb into dy. It's a simple theorem, part of the uh, ICSE syllabus. So uh, pretty simple to prove also. One of these I'll maybe in this lecture I'll in the comment section I'll put the proof of this theorem also. So it's a pretty simple proof. Okay, once we have this, then what this is what we get, that CD into dB. Let me show it to you. CD, this part CD, because this is now the unknown part. So CD into dB. This dB part we have calculated to be root 15. Now this is the only part that we need to consider. So CD into dB would be equal to this FD into dG. I'll clean it and then I'll show you again so that you understand this well. So what I'm going to use now is that CD into dB would be equal to FD into dG. This is the intersecting chord theorem that I'll be using. Now FD is equal to the radius of the circle. I know that the this radius is root 10. So root 10 minus this part. This is root 5. This part is root 5. This radius is root 1. So my FD would be equal to root 10 minus root 5. Root 10 minus root. So this multiplied by root 5 plus root 10. I hope this is making sense. So FD is equal to root 10 minus root 5, this part, and dg is equal to root 5 plus root 10. Let me write it as root 10 plus root 5. I hope this is making sense. Otherwise, you can rewind it by 3-4 minutes and look at it again. It will start making sense. Not very difficult. In case you face any difficulty, you can comment and I'll explain it again. But it's pretty simple. See, this part multiplied by this part is equal to this part multiplied by this part. I have calculated this. I know this, and this will help me get this. And what you need to understand is that once I have got this, then this plus this would be equal to the whole chord. So if you haven't understood, just rewind it by 3-4 minutes. I think 4 minutes, and you will get it again. So this is what I was trying to say: root 10 minus root 5 into root 10 plus root 5. Now this is a minus b into a plus b. This would be equal to a square minus b square. So this will be equal to 10 minus 5. This will be equal to 5. This is the 5. So CD would be 5 by root 15. I rationalize this. This would be equal to root 5. 5 root 15 upon 15. So 5 3 the. So this is root 15 by 3. And then I add the two parts, root 15 upon 3 plus root 5. See, this is root 5. This part, BD, sorry, BD is root 15. This is root 15. This is root 15. This is root 15. Root 15. And this part is root 15 plus root 15 upon 3. Root 15 upon 3. And here you can take root 15 common. 1 by 3 plus 1 will be root 15 4 upon meters. So this would be the final answer. So CB is root 5 into 4 by 3. So interesting question. I liked it because on the face of it, it almost seems very difficult, but basic class 10th problem. Uh, so I hope you like it, and let's meet in the next lecture. Thanks for watching.